uh, everybody. I think you have received our book uh, and you have finished your assignment and you have learned the central tendency, variability,
Yeah.
these two parts you have already learned. So today we'll take 15 minutes time for discussion related to application of statistics in safety management. So can anybody tell about the how mean, median, mode they are helping in accident prevention or in safety management? Can anybody tell?
Basically, it helps us to analyze the accident data or the cause of accidents, specifically the mode one. It helps to which type of accidents occurs frequently and or what are the reasons. So we can focus on that. So that accident data basically in the mode format we use to analyze.
So you are giving importance on mode. That means
In case of which, due to which reason, which other hazards or which other things that are getting repeatedly happening and behind the reason of an accident. So in that way, we used to understand the what are the main hazards, main risks are associated with that.
okay. Any other observation? So whether we'll follow the mean or median or mode.
Sir,
Actually,
hello.
mode will give me the maximum number of incidents which are happening, and mean will tell me just the average of overall performance.
Any other observation? Why do we follow mode, not the median, not the mean?
Whenever the frequency of a particular event is more, then we have to be more cautious about that event, which is determined through mode.
Okay. Uh, so what is the difference between mean and median?
Mean is actually the average value of a particular data set, while the median denotes the middle value of a particular data set. So sometimes it happens that there is a difference in data. Sometimes the lower side of data is clustered more in a data set in comparison to the higher side. Suppose we have a data of 5, 10, 15, and other data is around 80, 90. So if we will take the average or mean of that data, then it would be around the higher value. But the actually the average data lies between the lower numbers. But in case of median, it lies towards the towards the data which is more clustered. Suppose if there's a low number of data, then the median will lies in that range only.
Correct. Now you tell me that is mean, median, mode, which is called the robust statistics.
I think median and mode.
Not mode, median.
Yeah.
Now, can you tell me why median is considered as the robust statistic?
Because normally it is the central value of a given data set. So on the either side, value lies between the central value. So I think for this reason only the median will be, the more, suitable.
Actually, it is not affected by outliers.
Correct, correct. It is not affected by outlier. So what is outlier?
It is the extreme values.
Correct. So when we study the outlier of the data, then we can think about the 5 num. Have you heard this name? What is 5num?
No, sir.
Okay, so please you write down somewhere. That is 5num includes, first one is the minimum. Second one is the quartile 1. Third is the quartile 2. Fourth is the quartile 3. And 5 is the maximum. This is the total data range from minimum to maximum. So when we will handle any sort of accident data or safety training data, we have to consider these 5nums. Because in 5num, you can find out many categories of data. First category is the minimum, that means lower than the first quartile. Another one is the maximum, that is above the third quartile. And the data set within the range of first quartile and the third quartile. That is the indicator of interquartile range. I think this is clear to all of you. Now, can you tell how outlier affects the interquartile range? Can anybody tell?
Sir, it may affect the quartile range actually, or maybe in minimum range. If we consider outlier beyond minimum or beyond maximum, so it may interfere with your quartile calculations.
So if you find the data, that is extreme data, in the maximum side, then you will find the data set becomes very small. Okay. But if you find the data set where the outlier lies at the minimum side, then you will find out the distribution. Again, it is small to the upper end. That means your data set that is dynamic in nature, because your data is always affected by the outlier. So when in the analysis, we will handle the outlier, then we must be very much cautious whether you keep that outlier or not. This is clear to all of you?
Yeah, sir, only one question. So how to identify outlier in the data range, maybe on the minimum side or the maximum side?
Okay, that's true. So I think Pritish, you can share the geometry. Then I can show you.
I think box plot shows that.
Correct, correct.
In case of box
Box
plot,
plot. By using the box plot, you can share. That is better. So now, thank you, Pritish. Now you try.
British screen is not visible.
Screen is not visible, no?
Yeah.
Now it's
It is coming.
It is okay now. I can see that.
So here you click the A, cell A1. First you click the cell A. Cell A, just you click the cell A. You have to make it because your A has the sign of balls. Okay, that means it is the nominal. So this is the categorical data. So you have to transfer this A into the continuous. Okay. So you click the variables. You click the variables, and then you click the edit A. Now you click the data type. It is written integer.
What to select?
हाँ decimal ठीक है. और it is written measure type. It is written nominal. You no upper. Measure type is written nominal. There is. You change it. Click it continuous. Correct. Now you data variable name is A. You write down the accident. Correct. Now right side there is one arrow. Just you click it.
This one.
Yeah. So now you will find the book type sign. Okay.
Okay.
Now you click this one, this book type data. You can click it. Now you have to enter the data under the heading A. So
Description.
click the data.
Okay.
After the variables, there is data. Yeah. Now you can find out it is accident. So here you write down.
But in this way, I can change the. Okay.
First you write down
In accident.
Here you write down 2. Below you write down 3. Then again 2. Next 4. Next 3. Next 2. Next 3. Next 2. Next 18.
18.
1 8. Next 3. Next 2. And next 3. Correct. Okay. Now there is analyze. You click it analyze. Click analyze. There is exploration. You click that one. Click exploration.
Yes, sir. Do I need to select all these things or?
Automatically, no problem. It is the third generation spreadsheet. Okay, so don't worry. You just click descriptives. Good. Now it is written accident that will be moved under the variable window. Correct. Now automatically you will find out the total data. So what is the mean?
Mean is 3.92. It is the average of all the entered data. Then is the middle one. And standard deviation. Minimum data was 2, maximum was 18. N is the total number of 12 data was there.
Okay.
And missing is 0. 0 was not there.
So how you can interpret this data? This is the accident data for 12 months. Now interpret the data.
This is 12, I mean, per month data, right?
Per month data.
Per month, 12 numbers. So per month, that number of incidents has occurred.
Yeah.
So, okay, in a particular month, 18 was the maximum. In a particular month, 2 was the maximum. And there was no month where accidents did not occur. So every month something that accident has occurred. But mean value and median value.
So what are the decisions you can take related to this data? Safety decision.
Actually, sir, in a particular for this category accidents, actually, sir, what we do is mainly focus on why the accidents has occurred. Means it is basically the numbers, how many numbers of accidents has occurred in the entire year. So mainly what we focus is on the reason why the accidents and things have occurred. So this is just number. So number basically which if we want to based on numbers, particular time in which time that number have occurred or particular which month these are, this might help in, but particularly this mean and median and standard deviations, I'm not so clear how it will help.
Okay, now you click the statistics. Below the statistics is there. No, below. You click it. There you can find out mode. You can click the mode. Okay, so you will get the mode also very quickly.
Okay. So what are the requirements? I can select it or deselect it from here, the statistics.
Yes. Now you can click the skewness distribution, data distribution. Next is kurtosis. You click it.
Actually not aware of this one, kurtosis.
If you read our book, now we have given you book. So please you read that book.
Okay.
Okay. And what is your skewness?
3.34.
3.34. And the kurtosis is 11.4. Okay. Now you go below.
This one?
No. Go below. There is a plot. You click the box plot. Yes. Now you interpret this data.
This one is 5, 10, 15 means this one is the number of accidents. And this one not mentioned. 9.
So what is your mean? 3.92, no?
Mean was 3.92, yes.
So if it is 3.92, then means, and the median also 3. So now you can find out the data that is highly affected by the outlier. Outlier is
18.
18.
This one.
Correct. Now you go to your data set, the original data set, and you, instead of 18, you write down 1. Enter. Okay. Now you will find out the data. And you do not find any outlier. So,
and I guess this is the total means minimum.
This is basically your,
and this one is quartile.
This is
one,
the interquartile range.
And this one is the interquartile. range.
Interquartile range.
Understood.
Huh? This is clear?
Yes, sir.
So we have understood that due to the presence of outlier, central tendency is affected.
Sir, actually, I have one just doubt.
Hmm.
Maybe sometimes like outlier also might help us uh, in real scenarios. Now, suppose this is
Correct.
a scenario. Outlier might help us to identify there is a sudden jump in incidence in certain month. So we
Correct.
may
Correct.
identify what is the reason for jumping in the or increase in the number of incidents, and that may be helpful
Very
in the
good.
analysis. The reason, what is the reason, and all these things. That also can be you outlier can also be useful for data interpretation. Maybe
Oh,
in
sure. That
isolation.
is also true. We cannot delete the outlier. Huh? And if we delete the outlier, then we have to write down that is why we have deleted the outlier. So to make the data parity, we can delete the outlier. But again, maybe due to some typing mistake, outlier may happen, or outlier is the actual incident. That possibility also there. Okay. Now I am coming to the another thing, that is the standard deviation. So now you will find again you calculate the statistics, you go to the statistics, analysis. You click analyze, descriptives. Now you will find out that is your standard deviation is low in comparison with the other event. Okay. Yes, now you find out it is 0 point something. So can you tell me when the standard deviation will be 0?
All data will be equal.
Correct. When all the data equal. Very true. Very true. So standard deviation indicates within group variability. Okay. Within group variability. Do you have any knowledge about the control chart?
No, sir.
Any idea about the control chart?
No, sir.
No ideas.
Control chart comes from statistical process control. So here you can find out the importance of statistics to control the accident It has been originally developed by Walter A. Schuhart at Bell Laboratories. This is the control chart.
Sir, are you
I-
showing something on the screen?
No,
Huh?
it is a precision screen, na.
Okay.
Huh.
I think it is also used for statistical process control.
Yeah. Statistical process control. That is the control chart.
জলের শরবত খাবি দেবো
Now, you
দেখ
click.
ভালো না লাগলে খাস না
Sudipta, please mute karo.
ও
Mute karo. Sudipta Mujumdar, she is the secretary of our trust. She has joined here. Achha, now you click the you go below. Pritish, go below. There is a plot. You click plot. You can click the histogram and the density. Histogram and density, both. You click it and run.
How to run?
You have to run. There is one arrow, na big arrow.
Achha, yes.
Click it. You go above. Maybe there it is.
This one is or?
No. This is the box square plot. I am telling histogram.
Yes, but
Is it there?
no, sir.
Why
Do I
not?
need to select all this or then or no?
The accident variable you have taken, na?
Hmm.
You have selected the accident variable. Just you click descriptives. No, you have not selected. You go up. No. No. Not this one. You click again. You click analyze. Then exploration descriptives. And then you go up. Because you have not selected any variable. Yes, that is the gap.
Okay.
Okay. Therefore,
first time actually using this one. Okay. So from there,
now
I have to take it to the variable. There, I have to select what I want.
Now you will find out. So this is your data. Okay.
This is histogram. Density and accident.
So here you will find out the.
Actually, density is the frequency, na?
Density, that is also frequency. And if you click the density, then you can find out whether the data follows the normality or not. And you will find the frequency of extreme data. So now you click, you go above. There is module. You click the module plus sign, right side. No, extreme right. Click. There you click the Jamovi library. Jamovi library is there. You click it. Now you click the RJ editor to run R code inside Jamovi.
Need to install it?
Install.
टॉप एरो ये नहीं क्या हो गया टॉप एरो एरो जामोवी ऊपर एरो है ना ऊपर ऊपर हाँ
This one, na?
हो गया ना अभी 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 तो ये तो इंस्टॉल हो गया नाउ व्हाट टू डू
And now you click R. Because Jamovi follows the R code. Okay. So when we do not find any specific statistics, then we can calculate that statistic. So you click the RJ editor. Okay, now you select accident. Okay. Now, below you will find out the summary.
This one.
Summary data. You click this summary data. First, you have to select.
Which answer I need to select?
Summary data.
Okay.
Then you
click this one, run. Okay.
Now you go below. So this is your summary data. Okay. I have told you the 5 nums. Here you can find out the minimum, the maximum, 1, 2, 3, 4, 5. You will get all the data. Okay.
Oh, yeah, that's 5 now.
This is given by Professor Tukey. Sometimes people say Taki and Tukey, whatever might be. Now, when we want to calculate the statistical process control, then we have to find out the upper control limit and the lower control limit. Okay. So you just write down data mean. Below the summary, you can write down data mean. Data, no, there will be no space. Mean, MEAN, equal to mean bracket data. You run it.
so this is the language of Jamovi basically which runs the backend R code
You can run and there's nothing there. because data mean is your vector. So whatever the mean value that is inside the data mean, okay, you cannot see it. Now you go below, after the data mean, whatever you have written, mean data, then enter. You write down data SD.
Data SP.
SD
SD, standard deviation.
equal to SD bracket data. Then you write down, you have to run it, otherwise it will not work. Maybe some mistake is there.
It is asking for data type double.
Data SD equal to SD bracket data. What happened?
Is asking for type double to type double.
Cannot be covered to type double.
Converted to type double. Data type mismatch. This is basically data type mismatch हुआ.
Oh,
Actually it was decimal रखा उसके चलते हुआ ना, but उधर तो और कुछ था नहीं decimal छोड़ के.
no, that will not affect. SD bracket data, that is the.
इधर definition करना पड़ता है क्या, double SD पहले SD का पहले double लिखना पड़ेगा.
No, I'm checking in my R.
Praveen, you are silent. सुनाई दे रहा है ना सब कुछ? Praveen, are you there?
Formula is correct.
हाफ पेज दिख रहा है प्रवीण? टाइप सिक्स सुनाई दे रहा है ना प्रवीण? तुम्हारा वॉइस सुनाई नहीं दे रहा है. We are not
यस
able
यस
to hear
सर,
you.
यस यस लास्ट 3-4 डेज से थोड़ा नेट स्लो है यहाँ पे, तो
हम्म
ऑफिस में भी मतलब पूरा भूटान टेलीकॉम ही डाउन था.
हम्म
अभी रिस्टोर हो रहा है, तो अभी भी बीच बीच में नेटवर्क मतलब 0 MBPS आ जा रहा है, तो शायद मे बी कि मेरा मतलब लॉग इन लॉग आउट करना पड़ रहा है अगेन अगेन अगेन.
हम्म, ठीक है.
Okay, I think your SD that we have calculated through the Jamovi directly, can you remember?
It was
Oh,
around
sorry. Yes, now I understand. Data equal to SD, then data dollar. SD after that data dollar. You have written a data bracket. You have written there. You write down data dollar.
Why?
Just you sign the dollar, then accident will come.
Run.
No, data, that will not work. Data SD you have written. You have written mean data. Okay. You have written summary data, na? You go below. After the summary data, you go to the next line.
After summary data,
Go to the next line. Just you write down. Instead of the data mean, you just remove the data mean. You write down data dollar. Data dollar. Yes.
symbol only.
No, those things will not be there. Only the data dollar.
Okay.
Then automatically it will take accident. No. Mean data will not be there.
So data dollar equals to
after the summary data,
बाकी सब डिलीट करना पड़ेगा.
हाँ, you just delete the 3 and 4. You delete.
इक्वल टू डिलीट करो. इक्वल टू रह गया ना, इक्वल टू को डिलीट करो. अरे डेटा डॉलर इक्वल टू, हाँ डेटा डॉलर इक्वल और
just you write down data dollar.
बस. Now run.
Data dollar accident is there, no? Because that this data is your data frame. Therefore, it is not able to calculate. It will come automatically, but I do not know why it is not coming.
But data dollar accident was coming, but
you write down data dollar accident, ACCID. যেটা ওখানে লিখেছি,
ছিল বাট এখন আসছে না. হ্যাঁ.
Now it is coming, na?
Now run.
Yes, now you get it. And what you have written? Data dollar
accident.
Okay, very small, I cannot see. Okay, correct. Now you enter and then you write down data mean equal to data dollar accident. Data dollar accident will come. That is okay. Now you write down data SD equal to SD bracket data dollar accident. Here data dollar I am using because the data follows the data frame. Therefore, it is not able. Now you write down next list, 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 bracket, data mean, comma, data SD. Comma. Then run. Okay, so you have noted the mean also. The first one will be the mean, another one will be the first one. Have you written mean?
Data mean, comma, data is.
No, data mean equal to mean bracket data accident. You have not written mean.
Sir, list bracket.
না ওটা না, 4 নম্বরে যাও, 4 নম্বরে দেখো ডেটা মিন লিখেছো ইকুয়াল টু ডেটা, তার আগে লিখতে হবে মিন। প্রথমে লেখো মিন,
ডেটার আগে
মিন ব্র্যাকেট
এবারে
স্টার্ট,
ব্র্যাকেট,
ব্র্যাকেট স্টার্ট,
এবারে একটা ব্র্যাকেট পড়বে,
ব্র্যাকেট ক্লোজ।
ওটাকে রান করা। এবারে এই 3টে লাইন ধরে একবারে ইয়ে করে দাও, রান করিয়ে নাও।
3টে লাইন সিলেক্ট করতে হবে, 4, 5, 6। Now run.
Okay, now you will get the mean as well as the standard deviation.
মিন
Okay.
তো 2.5 আসার কথা, মিন তো আসেনি। মিনটা 2 আসলো কেন? উপরে মিন 2.5
ওই তো
দেখাচ্ছে।
2.5টা দেখাচ্ছে।
আচ্ছা,
এখন তো এটা 1 আছে না, আগে ছিল 18 ছিল, তখন 3 হয়ে গেছিল। ওকে, নাও ইউ রাইট ডাউন UCL।
ওকে, আচ্ছা আচ্ছা।
UCL equal to data mean plus ব্র্যাকেটে 3 ডেটা মিন, তারপরে হচ্ছে
ডেটা মিন প্লাস
UCL, হ্যাঁ ডেটা মিন, then plus sign, after that bracket 3 into data SD, then you run.
Okay.
Accepted. Next you write down LCL.
LCL equal to
data mean
minus 3 into SD.
minus 3 into SD.
minus data
Bracket,
mean
bracket, within bracket.
data mean
minus লেখো।
अच्छा
minus
data mean
minus bracket start. 3 into data SD.
3 into
data SD. Run.
Run. Now you write down list. Bracket UCL or LCL. The vector name. LCL.
Run now.
Bracket
Run.
close. Bracket close, then run.
Run.
So now you can you will find out. So this is your control chart. Okay.
Upper control limit and lower control limit.
Correct. That means when you want to reduce the number of accident, then you have to think about the 6 sigma from the minus point of view, 3 sigma, and also the upper, that is also 3 sigma. Okay. Therefore, I have used the 3 sigma. So when you think about the 0 accident, then you have to think this control chart.
But just one question. We have assumed the data to be normal.
Data should be normal.
No, we have assumed that the data is normal distribution.
No, not necessary. That is not important here.
This will work with the non-normal distribution also, na?
Non-normal distribution also.
Okay.
Now you can plot your data. So you write down.
Plot the data, no?
Oh, not there. After the 8, 9, next you go to the 10th row.
Enter নিচে LCL list যেখানে লিখেছো নিচে।
আচ্ছা
enter.
You write down plot. Bracket data $accident. Okay. Then comma, type TYPE equal to, within double inverted comma,
type equals to मतलब
type
type equal to
type equal to
क्लोज करके
ওটা ক্লোজ করো এসকেপ মারো ইকুয়াল টু
type not bracket হবে না,
ব্র্যাকেট হবে না ব্র্যাকেটের ভেতরে
type equal to
Within
within
quotes.
double inverted comma L small L, then bracket close, enter, you run.
अच्छा
so this is the control chart.
No, this is your data distribution.
Okay.
Okay.
What is L? Type L. What
L
does
হচ্ছে line chart.
আচ্ছা, okay.
Line chart is not possible through the Jamovi window. Okay. So we have to follow the R.
আচ্ছা, তো backend it is R running to draw the graph. Okay. Achha, is it possible to copy this also graph? Possible to copy the graph from here?
Sure.
Achha, very good, very good.
You can do the analysis.
Okay, good.
Sir, but in Excel, you can plot the graph directly also, no? Because giving the data range.
But इधर बहुत easy है. ये तुम तो छोटा छोटा डेटा है ना. If you run 10,000 डेटा तो पागल हो जाओगे.
एक्सेल में होना नहीं.
एक्सेल में डेटा उतना डाटा हैंडल करना मुश्किल हो जाता है. इधर very easy.
Now there will be the two lines. One line will be the in upper control, that is the 4 point something you have written. Another one is the lower control is 0 point something you have written. So you have understood the upper control as well as the lower control. That is the control chart. So you can take the decision that is in this year, we will follow the upper control is this and the lower control is this. So whatever the accident will happen, that should be within that particular range, provided you have the good number of data. So here I have given some hypothetical data, but when you will deal, then you have to follow the good number of data because you have that data. Which is private data of Tata Power Plant. So that data you have, and this statistical process control can help you to make the proper decision about accident control. So this thing you can do for the different departments also, because you have the different departments. So you can do that analysis also. That is the operational, mechanical, electrical, and based upon that, you have to find out that is how can you manage the, or how can you prevent accident, or how can you minimize the accident.
This programming is same for all the data for plotting the data control chart, or this will be different for different data, or?
Yeah, so this is the, maybe this is the accident of one department. maybe in electrical department, another figure you will find out. Mechanical department, here you can find out different types of accident. So this is the initial phase, but this initial phase gives you this information, that is how much accident you can control. Then you can think about the types of accident and many other things. Okay, I think now you have understood. If you have any question, you can ask me. So here you have understood how to enter the data in Jamovi, how to modify the data pattern from the nominal category to the continuous category. And you have understood how to explore the data distribution. And finally, you have understood the control chart.
समीर
यस सर।
ठीक है, समझ में आ रहा है?
समझ में आ गया, लेकिन ये कमांड कैसे यूज करना है वो क्वेश्चन मैं पूछना चाहता था।
कौन सा क्या?
जो सारे कमांड्स हमने दिए हैं यहाँ पे,
अच्छा,
तो हाउ टू यूज दोस कमांड्स। अभी तो सर ने बताया तो इसमें सब रन हो गया, बट इफ वी वांट टू डू इंडिपेंडेंटली then how to use those commands.
तुमने
Please
लोड
you
कर
write
लिया
down
क्या?
all the commands in the group. Whatever the commands I have told you in RStudio, so you please write this command. Okay.
Sir, are these commands available in that book?
Then, no, because today I have given you the control chart command that is not available in the book. Since I know the theory, therefore I am giving you this. Okay. You can do it later on automatically.
I
This is
think
just like a
nowadays everything is
calculator.
available in the help also. Help should also be there. Jamovi should also be having help, na? Help should be there. ऊपर डान दिख देखो तो, डान दिख डाइने इधर नहीं, डाइने ऊपर, हाँ हाँ इधर हाँ नहीं, उसका बाजू वाला लेफ्ट वाला, ये क्या है? नहीं, ओके, देयर शुड बी हेल्प। आई थिंक कहीं पे भी हेल्प रहना चाहिए। नॉर्मली दिस टीम्स हैव हेल्प।
In our book, you will find the R codes. Okay. I have given you the book, and in that book you will find the R codes. And since you are dealing with the control chart, statistical quality control, Professor Mahalanobis has given special importance on statistical quality control. And in the Indian Statistical Institute, we have the one unit on statistical quality control. So they are applying different models of statistical quality control. Professor Maulanavi suggested many things. I think you know about the Six Sigma theory. So I'm just sharing my knowledge, okay? So that you can think about the, is it possible to control the accident? If possible, then how statistics can help you in decision making. Okay. Now it will be over to Pushmita.
So,
Pushmita, are you here?
Yes, sir.
Yes, Pritish, now you can close your screen sharing. and Ushmita will present now.
Hello everyone. As Sir was teaching the commands of our studio and Jamovi, since today's class is based on a reflective journal style technique, I have curated a Word document of sorts that I will be sharing on screen over here. And I would like responses from everybody in how this course is helping you understand about safety management, disaster training, and etc. So I'll just show the document for the time being. This is something that I will also be uploading in the Google Classroom so that everybody can fill out the interactive journal. In the very first beginning, we have the name, program, course, date, and name of the plant industry. And then you can choose the nature of operations. And from here, I think common safety issues that have been observed. I think from here, we can start our discussion. So is anybody willing to go first?
May I try?
Yeah, sure, please.
Yeah, so common safety issue observed, we can, means if we want three major issues, we can divide. First one is issues related to the personal protective equipments. So there is a
Okay.
gap in the wearing of the personal protective equipments, like wherever required, safety helmet is not worn or safety shoes is not worn. In case of welding, the welding related PPEs is not worn, hand gloves not worn. So number one is PP related issues. Number two is issues related to the tools and tackles. So defective tools and tackles may be used, like the means welding machine which is not certified, or the lifting tools and tackles which is not certified, that is used. So that is number two. And number three, we can say that the unsafe acts and unsafe conditions. So there are some standard procedures are there, but persons are not following that. So they are doing it by doing unsafe act, and there may be existence of some unsafe conditions which may lead to the safety issues. So these three we can means we can say as the major issues.
Okay, that's very nice. Anybody else would like to try? Anything
About
other
shift,
than the three conditions that have already been listed over here?
starting up work without getting the permit, without documentation or recording of the activity. So work is being carried out. So it is in short with the work without PTW.
Okay, so poor documentation of workflow. Can I list it as that?
Yeah. Yes. Just in short,
Okay.
you can write work without permit.
Work without permit. Okay. Anything else?
About shift here is mentioning about the highest number of incident the shift. So night is you can select night is more vulnerable here.
Okay, that was anyway our next question. So, which shift experienced the highest number of incidents? So, as you were saying, the night shift. Um, Anybody else feels the morning or afternoon? You feel a lot more accidents happen?
It can be evening time also, as everyone is hurrying to go home.
Okay, okay. So, evening time, night and evening time. I am listing all the answers in the chat box so everybody can go through it.
I think one of the major is the shift changeover.
Shift
Morning,
changeover. Okay.
morning, evening to night.
So shift changeover and evening time, especially, I think Sejal ma'am had mentioned that everybody is rushing to go off home. And the night is, in general, I would say everybody is some sort of a sleep deprived, right?
Lack of attention is because the biological clock works differently at night. So basically, people heavy work at night is normally not good.
Okay, okay. Lack of attention. Heavy work at night. Okay. Next, we come to applying uh, the basic statistical concepts. In the first section, we have just got an overview of the type of accidents that do happen and when they happen. So now we will be applying the statistical concepts that we are learning to these. So the very first one was frequency distribution. So over here, as you just have to say that in the last how many months the total number of recorded accident was and what was the most frequent type of accident. So in the frequency distribution section, we are trying to collate all the accidents that have happened throughout the past 1 month or 2 months and trying to understand the most frequent type of accident that has happened, indicating the mode, statistical mode of the accident that is happening. So can anyone please um, enumerate on this? It doesn't have to be actual figures, but an estimation would also work. Anyone?
Can we consider near miss here or it's only accidents?
I think full-fledged accidents.
Actually, the problem is that as far as the actual data goes, we do not have too much of accidents. Maybe
Okay.
in a year, 2 or 3 maximum in a year,
Okay. Okay.
and covering all the plants. So we do not get so much. What happens is we get a number of observation where we can classify based on category. So basically, this is a proactive mode of managing accident. So when we get the observation, based on that, corrections are done so that uh, any future recurrence can be, of
Okay.
incident can be avoided.
Okay. Okay. So, given the new information, we let's not consider the complete accidents, but we can consider near misses that have happened. So you can give your data based on the near misses as well.
So we can consider here in the last 10 months, means for this financial year,
Yeah, okay. So
the
it's in the
total
last
number
12
of,
months, then it would be.
yeah, 12 months, the total number of near misses are, it's 24,
Okay.
2 per month we can consider.
This is 24. Okay. And what was the most frequent type of near miss that had happened?
It is a fall of material from the height.
Falling materials.
Fall of material from the height.
Okay. Fall of materials from heights. Okay. So, if I consider this, that in last 12 months, a total near miss of 24, almost or near miss accidents that had happened, and most of them were regarding of materials falling from great heights. What do you think this suggests? A pattern that is possibly there in the power plant, or how is putting these accidents or near misses in a frequency table, or what sort of insight will you be getting if you list it in a frequency table manner?
So if we put it into the frequency table, we can get the insights like from which department most of the near miss, means highest number of near miss has occurred. What was the means the timing, whether it was afternoon or what was the time of the near miss? What was the skill level of the worker working in the area, whether it was skilled or unskilled, and means which section of the plant which is mostly affected by this near misses.
That's a really good feedback and insightful, actually. So thank you so much, Samir sir. Anybody else would like to contribute to this, or shall we move on to the next measure of central tendency that we have?
Let us move on.
Okay. So if I consider the last data, 12 months, near misses of 24, that means average mean of number of accidents per month would be 2, and median number of downtime hours due to the accidents. I don't think this will be as much necessary because they are not full-fledged accidents, they are near misses. But the mean is very important, in which we can understand that at least two number of near misses are happening every single month. And did anybody get injured with these falling materials from the height, or any kind of
No, then it will
safety
not be a near
concern?
miss, it will be an incident.
Huh?
Nobody is injured, otherwise it will convert into an incident. No, it will not be a
Right,
near
right,
miss.
right. Okay, okay. So then if the mean accident rate, suppose if the mean accident rate from 2 per month increases, what would that be suggesting to you? Let's consider the increase first, and then we can consider the decrease scenario. If the near misses tabulations, while doing the tabulations, frequency distribution, central tendency, you see that the mean number of near misses increases. So what does that suggest to you? Anybody?
If near misses are increased, then whatever the controls we have applied in terms of our means documentation procedures like work permit system or the whatever the documents we are ensuring, it is not working well, or the communications whatever we are doing like toolbox talks or trainings, the that is not effective, and that's why it is keep on increasing.
Okay. And how about if it decreases?
If decreases, then those trainings and controls are very well understood by the workers. They are implementing it, and ultimately it is resulting into the decreasing of the incidents.
Absolutely. So if we see that the mean value is decreasing, that means we can say that whatever intervention or treatment that we are providing to reduce the number of accidents or near misses are actually working. And in the direct opposite, if it increases, then we know that something is not right. Either the training is not working or the intervention is not working, or somewhere there is some sort of shortfall that is happening, which is leading to the increase in the near misses or the number of accidents. Next, we have measures of dispersion. Over here, we are trying to understand what is the mean median mode, and from there, what is the range of the accidents or the near misses that are happening across all plants. So, for the range of accidents across departments, there are various safety departments that you all hail from. So, over here, that we can write. And standard deviation, if it's available. Along with that, if the accident or the near misses that are happening are extremely consistent or it's extremely variable. For example, if in 2 months continuously you are having the number of near misses based on falling materials from a height, but for the next 4 or 5 months a different kind of accident is happening altogether, or a different kind of near miss is happening, maybe equipment near miss is happening. Okay, so that is the range, and from that range, we are understanding the variability of the accidents, incidents, or the near misses that are happening. Okay. Now, based on this near miss variability, as we understand, what does that suggest about compliance or supervision? What do you understand from that? In case if you are unable to understand what I'm trying to convey, please go ahead and ask. I'll explain again.
Please explain again. I think it is not clear.
Okay. So as I was saying that in the last, maybe in the financial year, 2 months consecutively, you had near misses of uh, falling materials. Okay. And for the next 2 or 3 months, you had equipment based near misses. Maybe equipment malfunctioning or PPE protection was not worn by workers. That is why you had a near miss. Okay. And again, after another 2 months, you again have another incident of falling materials from height. So you see how there is a variability or a range of near miss or accidents that are happening in the power plant. Now, what does this variability or this range of accidents suggest to you about supervision and compliance protocols in the power plant?
So
Is it
about
clear?
for the question is clear now. But it depend upon the scenario. For high range variability, as you said, for PPE we need to look for different control measure. For follow material we need to look for different control measures. So there is a different system we need to analyze what went wrong. That's why this was happened and recorded. So we need to look for this.
Okay. Basing on what you have said to me, Praveen sir, in tomorrow's class, we will be covering theories of disaster management. Over there, there are two theories that I'll just slightly, highlight. One is the single factor theory, and another is the domino theory. So, according to the single factor theory, it suggests that only one factor is responsible for the disaster. For example, you must know that how Japan is very prone to earthquakes. So, according to the single factor theory, if a building collapses in Japan, it is because of the earthquake tectonic activity. Okay. However, the domino theory suggests that it accidents are not based on just single factor, but it is due to a series of consequences or failures that happen continuously. So it is, if a building collapses in Japan, it's not just based on the earthquake, but it might be based on poor construction, poor land regulation, and etc. So since one failure, the other consequenting acts or events are just based on the previous failures. So here, also, as you have suggested, that for variability to understand supervision and compliance, you have to go through all the things that were taken into account to ensure the safety of the workers and PPE kits and etc. These theories that we will be learning tomorrow will help you understand these concepts far better. I hope till now it's clear for everybody before we move on to correlation analysis. Shall I move on?
Yes, yes.
Okay. Can anyone just identify two variables that may or may not be related to each other with regard to safety training or accidents that happen in industrial power plants? Anything.
Again, please. Not clearing.
Just select two variables that are related, that may or may not be related for accidents that happen in industrial power plants. For example, overtime hours and accident rates. So just any two variables you can select.
Number of years of years of experience versus accident rate.
Okay, very good. Variable 1 is number of years of experience and variable 2 is accident rate. Now, what do you expect this relationship to be? Positive correlation, negative correlation, or no relation at all? If you want me, then I'll let you know what is positive correlation and what is negative correlation. Correlation refers to uh, the relation that two variables have. It doesn't have to be a cause and effect. It just gives us the magnitude. Like I was saying in the last class also, if one variable increases, the other will also be increasing. That is positive correlation. And if one variable decreases, the other variable increases. That is negative correlation. And no relation means that these two variables are not related to each other at all. So according to you, Sejal ma'am, what do you expect the relationship to be like? Number of years of experience and accident rate.
My word could not be accurate, but it can be negative correlation.
That's actually correct. That's very good. It is negative correlation because we expect that the number of years that a person is working in a power plant, the rate of accidents that he engages himself with will be lower because he knows to be cautious, he knows how the instruments work, and he knows the safety protocol that need to be followed. Okay, so that's a good response. Thank you. And from there, we move on to probability risk estimation. Probability risk estimation is basically the probability of accidents that happen during peak production season. How many accidents or how many near misses can happen during the peak production season? And what is the probability of accidents within new employees? As you have said, somebody who has experience in the power plant for a longer amount of years and the people who are new joinees who have just completed their training and who have joined the power plant, the probability of accidents among the new joinees will be far higher than the people who have already experience in the power plant. So based on this, you will understand, based on the probability estimates and the risk factors that you are taking into account, you will be understanding which group requires more focus, which group requires more training, which group requires more supervision. Okay. Then we have a few graph charts over here that basically help you understand different trends and analysis. So here there's a question like which type of chart would be most useful in your power plant? A line graph. This is a line graph. It helps you to understand the trends that have happened throughout. So suppose in the year 2003 to 2004, what was the trend like? And from 2004 to 2005, was there a dip or was it consistent? From 2005 to 2006, we have an increase in the IOIDR. These are different components that have been used to curate this line chart. So a line chart is basically used for trend analysis. Then we have a bar chart. That is this. A bar chart. A bar chart is basically used a departmental comparison. Both of these are bar charts. So how many traffic accidents was there? If there were any injured foot accidents in the year 2015, 2016, and 2017. So the blue one is 2015, 2016 is the red bar graph, and 2017 is the green bar. So you can see the different type of accidents that have happened over the year and a complete visual comparison. A complete visual comparison of each of the accidents or type of accidents that have happened over the years. The pie chart hasn't been listed over here, but I'll just draw and show you what a pie chart looks like. So suppose this So suppose this is a pie chart. The entire degree is 360 degrees. Now I can say that maybe perhaps this area is 56% accidents related to PPE kits. Okay. Can everybody see?
Yes.
Okay. And then I can say that this area is maybe 59% related to equipment fail accidents. So if you put data in Jamovi, R, or even Excel, these charts can be created and they can give you a visual identification of all the types of accidents that are happening at the power plant and also the percentage of accidents that are happening. As I can see that 59% equipment fail accidents is far more than the PPE kit accidents that are happening. And maybe falling materials can fall in one of these two categories. So these are just examples of how visual analysis can help you understand trends, can help you understand the type of accidents that are happening, and can help you analyze whether the treatment or the intervention that is being given to the employees, to the workers present in the power plant, if it's helping them or it is working otherwise. Okay. Okay. Next, we move on to the statistics and behavior safety development. So measuring unsafe behavior. If what is the PPE non-compliance rate? What is the near miss reporting frequency per month? Training attendance, whether the trainees are attending the trainings or not, or whether they are skipping it. If they are skipping it, how are they performing on field? Do employees improve after feedback? And what is the evidence that you have that you are getting to understand whether the facts that are being reported in this reflective journal is actually worth substantiating? with on-field activity. Then we have behavioral insight. Before learning statistics, what did you think were the main cause of accidents? After applying statistical tools, how do you think accidents are influenced by? And how this change in your professional thinking was brought by? So I think this would be a better section that we can come back after we have learned quite a few bit of statistics. And lastly, what are the challenges that you face in applying statistics to the work that is being done? So, if there are any incomplete accident records or underreporting of near miss incidents, lack of statistical knowledge among supervisors, resistance to transparency, and other time constraints, which is the most significant challenge, and why do you feel so? Lastly, we have the action plan, that is data driven safety strategy. Based on all the data that you have input in this reflective journal, what are the three statistical safety interventions that you will be undertaking? And what is the time frame for that implementation? And what do you expect that outcome to be? This this section is a part of your goals that you set for yourself and for your employees. This has to be realistic. This has to be something that is achievable. You cannot expect to write write extremely high goals which you know will not be able to be fulfilled in the time frame that you are writing over here. So this has to be as realistic as possible, and it should be achievable. As long as it is achievable and you do achieve it based on the expected outcome, you can reset the goals and rewrite them as you move forward. And this is a part of the final reflection. So, how basic statistics has changed your understanding of accident prevention, how you plan to apply statistical reasoning in future safety management, and the role of data in shaping safety behavior culture. This part again, we will be coming back to later once we have learned some more of the statistics. So for now, this is the reflective journal that has been curated for you all. I will be uploading it to the Google Classroom. I want, as and when how you are learning about statistics, I want you to come back to this reflective journal and jot your thoughts down, jot the number of near misses or accidents that are happening, and how statistics is actually helping you to change that, and how it is changing you to change your perspectives in safety management. Then we will understand how this course is actually helping you shape the future of the employee training, safety management, and disaster management. I hope if there is any questions, please feel free to ask. If there's no question, then I would say that, sir, I am done over here.
Okay, thank you, Rashmita.
Thank you, sir.
Today, we have learned basically the data, which is metric data. And tomorrow, we will learn the data that is not the metric, that is the non-metric data. So how we can use the non-metric data for safety management or prevention of accident. And also the theories. We have to learn some of the theories. We have designed our course following the principles of Ravindric psychotherapy. Because the Ravindric psychotherapy assumes our consciousness has three layers: Murto, Rag, and Saraswat. So Murto means behavioral, that we can observe. Rag means emotional, and Saraswat means meaning of the event. So to achieve that meaningful journey in your learning, we have to follow some of the systematic procedure. So please do not miss the class and always follow whatever the instructions we have provided to you strictly. Then you can learn. So how is the class today? Any feedback?
The class was very insightful. Today we learned about Jamovi software, from where we can directly calculate the statistics of the from the given data set. So I think it's well, the new thing we have learned. So thank you so much.
Okay. Any other observation?
Yes,
For
sir.
me,
Yeah, yeah, Praveen.
what I understood during this class is that this is helpful for the large data to analysis to get the result to see some to look for the your objective. But what I am again, it is curious for me. I think for also for other also this how it will going to help us because our data is very less in aspect of accident. We have very less number of accident, even though very less numbers of near misses, but the observation is more. But how it will correlate and will give the certain direction, this is curious still for me.
Okay. So you can analyze the data across the different years. Okay. Then you can find out the trend analysis for the different types of accident. That may be possible. Maybe your data is small, but you can find out
Yeah,
the trend.
yes, sir. Train analysis, what you said, just said train analysis. In starting, Anand sir also said ki, we are doing this train analysis on the Excels. We are right now we are using this bar chart, line to show the management of this line chart, bar chart, pie chart, all those things right now we are using with this current data. But how it will again applied static will help. Again, it is a question for me.
Okay. So
Because we are all 9 10 candidates are from the different plants, and all plants having their own challenges, different trend of accident, different trend of near misses. So we are not calculating every time on a single platform for all divisions, all the plants at uh, location, means one platform. We are calculating for their our own individual plants with the less data. So that's why I am again and again telling ki how it will help. This is still question for us.
okay. So whatever the statistics you have learned, that is not necessary. That is, everything will be following the accident data. You can take other data also for your analysis, for your decision making. We are providing uh, the accident and the safety type of data because this is the part of our TOT model, which has been approved by Tata Power Plant. So if you want to know the final data, how we can do the psychometric analysis, then you have to learn many things because we are handling very large number of data. and we are facing a lot of the trouble because of the missing data and also the outliers. So if you want to do the psychometric analysis in your own plant, then you can collect the data. So all the data, maybe you can study the attitude towards the accident or attitudes towards some of the training program, because regularly you are maintaining different types of training. So what is the effectiveness of that training? That you can study also. Professor Maulanovic taught statistics in the desert. Can you imagine how he collected the data, how he taught sampling procedure? Since you are the researcher, you have to find out which data you will take and which data you will not take. Okay. This is vital. Any other observation about the class? Yes, Objesh sir, you are telling something.
I think Anand was trying to say something बीच में. आनंद कुछ बोल रहा था.
हाँ नहीं, वो क्लैरिफाई हो गया एक्चुअली. जो पहले ही क्वेश्चन पूछा था ना उसका, नाउ इट इज ओके.
प्रवीण एक्चुअली क्या ना, हमारा जो डेटा है ना, सी देयर आर सो मेनी ऑब्जर्वेशन, तो उसको कैटेगराइज करके यू कैन डू लॉट ऑफ एनालिसिस. सो विद दिस कंट्रोल चार्ट्स यू कैन डू समथिंग. ठीक है ना. पहले तो डेटा कलेक्शन इज इम्पोर्टेंट, देन क्वालिटी ऑफ डेटा. क्वालिटी ऑफ डेटा अच्छा रहेगा तो बहुत सारा चीज यू कैन डू.
Yes, yes, sir. That's why I told ki this is curious. We are curious for this how it will going to help actually.
हाँ, तुमको डेटा चाहिए. डेटा तुम्हारा अभी कितना आ रहा है महीना में?
मेरा तो सर अभी जस्ट स्टार्ट ही हुआ है तो
हाँ, कितना आ रहा है? जस्ट फॉर अंडरस्टैंडिंग.
120 130 मैक्स.
महीना में.
यस यस.
आई थिंक यू कैन एनालाइज दैट ऑल्सो टू फाइंड आउट अगर कैसा स्ट्रक्चर किया पता नहीं. डेटा अगर स्ट्रक्चर्ड है यू कैन फाइंड समथिंग. You can try analyzing that.
Sir, I think today
अभी तो
we have learned about
अभी तो जो अपना
metric.
कन्वेंशनल मेथड है वही एक्सेल से वैसे ही कर रहे हैं अभी तो फिलहाल.
क्या बोल रहे हो?
सर
अभी
प्रीति
जो
बोल रहा था.
प्रवीण कुछ बोल रहा था. प्रवीण का सुन लेते हैं पहले. प्रवीण क्या बोल रहा था?
अभी जो आप बोल रहे हैं ना जो डेटा उसको एनालिसिस करो, सो जो
हाँ.
कन्वेंशनली अपन कन्वेंशनल मेथड से जैसे करते आ रहे हैं एक्सेल पे, अभी तो फिलहाल वैसे ही करते हैं.
अच्छा ठीक है, वी कैन स्पीक ऑफलाइन हाउ वी कैन डू डिफरेंटली. ठीक है. हाँ प्रीतिश.
I was saying कि metric data तो आज हुआ. I guess sir was telling कि non-metric data का भी analysis next class में करेंगे. So I think after seeing the both these things, we'll be able to
right.
बोल पाएंगे, है ना. तो confusion प्रवीण को हो रहा है. I think non-metric data के केस में हम लोग ज्यादा useful कर पाएंगे मे बी. तो दोनों का चीज कवर करने के बाद we'll be able to figure it out.
ठीक.
Praveen Kumar, sir, what is your observation?
So today's session was very useful, and whatever we did in the our assignment number 1. So today we understood in detail, And but as the others said, it's once we will understood about the non-metric data, then we can figure it out for the metric and non-metric data. But overall, today's session was very useful. Want to learn more about Jamovi, because Jamovi is a good tool, but want to understand in detail the how the commands work in the few minutes, next sessions. Thank you.
Thank you. If you study our book, no, the statistics, there you will find out a lot of the R codes. At
Right.
that time, we do not have the Jamovi. Later on, we find the Jamovi. So, statistical software is changing very rapidly because the needs are different. When people are thinking about the dynamic data sheet, then Jamovi comes, and Jamovi follows the R script. Shejal, can you tell something about? Hello, Shejal. Okay, maybe she is not available here now. Okay, thank you, everybody. Tomorrow I will be in Tirunelveli for psychometric assessment. So,
When you are
I
leaving in
hope,
the morning?
yes, in the early morning we'll leave, and maybe at 6:30. Our flight is 8:45. We'll reach by 11:25 at Chennai, and
Then
after
from
that
uh,
we'll go to the Tirunelveli, Tuticorin.
Tuticorin.
Okay, thank you, everybody. Best wishes to all of you. Please
So
follow all our instructions.
Next class is tomorrow, is it?
Next class tomorrow.
Tomorrow at 7.
At 7.
Then and Sunday, ऐसा है?
Then Sunday, again Sunday, Monday.
Okay, Sunday. अच्छा, okay. ठीक है.
Okay, thank you.
Okay,
Thank
thank you.
you.
Thank you.
Thanks.
Yeah, thank you.